Configuring static routes and RIP in Palo Alto firewalls. So let's go ahead and configure static routing, and then we will move on and configure RIP in the Palo Alto firewall. So what I will do is I will pick this distribution switch, which is actually a layer 3 switch, and I will create some loopback interfaces here from, let's say, a 20 range, 20.1.1.0/24, and I'll create another one 2.0/24, and I'll create another one 3.0/24, and I'll create some loopback interfaces here on the Palo Alto firewall from 10 range, so 10.1.1.0/24 and 2.0/24 and 3.0/24. I will go ahead and convert this interface from layer 2 to layer 3, because by default Cisco switches, when you take them out of the box, they would be placed in as of layer 2 interfaces. So we'll go ahead and convert this from layer 2 to layer 3 interface, and then we will be able to assign IP address to this interface. So from this range, 1 is here. So what I will do is I will assign this as of an IP of 192.168.1.2 here, 1.2. And so let's go ahead and configure static route first between these two, and then we will configure RIP. So let me go ahead and configure these loopback interfaces on both of them first, then we will jump to the static route creations, and then we will configure RIP. So let me get rid of these so let's go ahead and access the distribution switch. Show IP interface brief. So as you can see, I do not have any networks here on this switch. So what I will do is I will go ahead and even change the host name to dist, let's say, switch, and I'll create the first loopback interface 10.1.1, sorry, 20. It was actually from 20.111 24, and interface loopback 2, IP address 20.1.2.1 and 3, so 3.1. do show IP interface brief. So as you can see, I have 3 loopback interfaces here. Now if I go ahead and try to ping or try to reach from PA central side to any of these loopback interfaces, I should not be able. So let's give it a try. Let me log in, admin, and if I try to ping from a source of, let's say, this IP address, which is 192.168, sorry, source 192.168.1.1 to the destination being a host of, let's say, 20.111. So the destination host is right now unreachable. So let's go ahead and log into this PA central site Palo Alto firewall, and admin. So it's again giving me that you are using the default username password. We will change that in some point. So what I'll do is I'll go ahead and create loopback interfaces here first. So we need to go to network tab and interfaces and loopback and add. So the first one, let's go ahead and create a loopback of 1. You can give a comment here. I don't want to attach any NetFlow profile right now, and I want to place this in the virtual router, default virtual router, and the security zone I can put it, let's go ahead and put it in inside, and IP is, let's say, 10.1.1.1. Let's go ahead and assign 32 one host here, and I want to attach the management profile which we created. We would create we will go through all of this later on. So right now it's static routing, so we could go ahead and create the management profile from here there, and then attach it. We already created from the previous session where we allowed only ICMP echoes to be accepted and replies should be sent back. So I will attach that management profile. Okay, I'll create another one, 2 this time, and attach the default virtual router and inside and IPv4. So it's 10.1.2.1 this time, 32, only one host, and the management profile. Okay, and the third one, which is 3, default, inside, and the IP is 10.1.3.1. I'll get rid of the other one, delete, advanced, then I attach the default and the security zone. So before committing, let's go ahead and create static routes for the networks that are created in the distribution switch. So I need to go to virtual routers, and the only one right now is default virtual router. We can create other one, we will create in some point in maybe another video. So I'll click on the default virtual router, and we need to go to static routes, and here I have only one default route that's pointed to my service provider, to this IP address. For any network, any mask should be forwarded to this IP address as the next hop, and the admin distance is default 10 for the static routes, because in Cisco you have for the static routes the admin distance is 1, and for the connected it's 0. However, here for the static routes it's actually 10 by default. Even metric is 10, but the admin distance for static routes are 10. So let's name this the first. Let's go ahead and say maybe inside lat 1 or inside network 1, whatever. So I will say inside lat 1, and the network is 20.1.1.0/24. For this destination network, send the traffic out of this interface. Which interface? 1.2, I guess it's 1.2. So for this destination network, get out of this interface, which is Ethernet 1/2, and you want the IP the traffic to be sent to an IP address or next virtual router. If we like a virtual router in Cisco routers, we have something called VRFs, virtual routing and forwarding, where in a single box you create virtual routers. Like similarly, you have VLANs, you can create separate VLANs. Analogically, I'm giving you example here, like in Cisco firewalls you have something called security context there. Now here in Palo Alto firewalls you have virtual routers. We also have something called virtual systems, which we will talk about later on in this Palo Alto training series. So if you want it right now, the traffic for this destination network to be sent to another virtual router, so you can select this, or if you want it to send to an IFQDN, fully qualified domain name, you can send and specify the domain name here, the fully qualified domain name. If you want for this destination network, if traffic comes into this firewall to be discarded, you can say discard. It will not ask you for any IP address or any further information. If you want to do nothing with it, you can say nothing. And in this case, we will go ahead and specify an IP address. So I'll select IP address. So the IP address is 192.168.1.2 in this case, which we have not yet assigned. We'll go ahead and assign it in a moment. The admin distance is by default for the static routes 10. If you want to modify, you can modify it here. If you want to, let's say, if you may have multiple paths to be reached, if you have two different paths, maybe one is from here and another one may be from some other path to be reached to those network or that network, and you want to maybe prioritize one over the other, you can either tweak the admin distance for that, or maybe you can tweak the metric value. Let's say maybe the default is 10 here. Maybe you want to say 9 for one. You would the lower is better in both cases. So the lower information is better here. And you want this static route to be installed in the unicast routing table or the multicast routing table. So right now unicast is being selected, or if you want it to be installed in both, you can install that, or you don't want to install in any one, so you can say no install. Maybe for temporary purposes there is a project going on, so you want to create the static route and you don't want to install it, and later on you just need to come and modify from no install to install. So you can do that. So right now we'll go ahead and select the unicast. So bidirectional forwarding profile, we will talk about this in the routing protocols. It will give you more sense there. So we'll leave this right now. For path monitoring, what you can do is, if let's say you have, maybe for path monitoring, what happens is, let's say what you can do is, let me give you an example here. So right now I have this being as of my internet service provider, or maybe MPLS service provider, or maybe SD WAN, whatever type of services I'm getting from this service provider. And if let's say I have another ISP as well, and this is also maybe connected to my Palo Alto edge device, and let's say if I'm able to reach the Google, let's say DNS server from this and this, both of them, and 444 as well, let's say 444 as well from this or this. So what I would do in path monitoring is that I'll monitor this path to maybe this IP address or this IP address or any other IP address. Now I would say if I am unable to reach via this path to any of these IP addresses or to only one of them, then consider this link being down and fail over to this one. So that is what path monitoring does for static routes. Now, or even for any other routing protocols. Now let's go back to here. Let me get rid of this here. If I select path monitoring, do you want the failure condition to be any? You can specify multiple here, or if you want all. Now all means all, or failure any means that any out of maybe 2-3 rules that you may create. Now let's say if you go to add, I want to say let's say LAN 1, because right now I'm using this path monitoring condition for this network, which is inside, and this is the next hop which is in my inside network, and here I can specify the source IP address if I have multiple IP addresses. Now because I'm creating this static route pointing to my inside, so that's why it only shows me this interface and the IP address of this interface. If it was the default route or this interface pointing to outside, it would show me the outside being as of a source. So right now it's showing me the inside interface IP address, and the destination is, let's say, 192.168.1.2 in this case. Maybe if I had another link here, so I could go ahead and select that path, maybe another path here somewhere. So right now I have only one link. So for this network, if this goes down, then it will go ahead and consider that link being down and move on and fail over to the other one. So that's one. So right now I've said all. You can change it. You may have multiple 3, 4, 5 paths. Then you can say any of those conditions, then move to the other one. So this is path monitoring. I'll go ahead and say okay for this LAN 1, and I'll create another one for LAN 2. So inside, sorry, LAN 2, inside LAN 2, and the destination is 10.1.2.0.24. so the exit interface is 1.2, and the next hop IP is 1.2, and okay, that's it. And I will create, after this I will need to create that IP address. on the distribution switch. So I'll say inside 3 20.1.3.0 Ethernet 1 2, and it is 192.168.1.2, and I'll go ahead and say okay. That's all. Commit. Now for the path monitoring, if we come here to the static routes and the default one, now here we could say we could add the Google DNS IP address or maybe some other public IP address, and if that service provider goes down, so we can now select the outside interface, and the destination is maybe, let's say, 8.8.8. So if now this goes down, it will fail over to the other one. So let's say Google DNS. Okay, now you could add other conditions as well, and then select either any or all. So I'll say okay and okay here, and I'll commit these changes. And before testing it, we need to go and convert this interface from layer 2 to layer 3 and then assign an IP address of 1.2 here. So what I'll need to do is I need to go here, interface Ethernet 0/0. So by default it's switch port. What we need to do is to convert it from layer 2 being a switch port to layer 3 a routed port. So we will need to say no switch port to convert it from layer 2 to layer 3 and assign an IP address now of 192.168.1.2 and 24 mask, and that's it. So if I try to reach 192.168.1.1, I should be able to reach or ping this interface, because we have allowed we have attached the ping management profile here on this Ethernet 1.2 interface. So now if I go ahead and try to ping from the Palo Alto firewall to after the commit is finished, we should be able to reach those networks. So if I go here, let me go ahead and log in and ping from the source of 192.168.1.1 to the host of 21.1.1. So now you can see I'm able to ping the networks that are here, the loopback interfaces that we have emulated for the purpose of testing. If I try pinging, I'm also able to ping. If I try to ping, I'm also able to ping as well. And if I try to create static routes here for the purpose of pinging the 10 the IP addresses, the loopback interface that we created on the Palo Alto firewall, I should also be able. So IP route, let me create a static route on the distribution switch. So for 10.111, having a 32 being as of a mask, and next hop is 1.1. So if I try to ping now 10.111, so I'm able to ping 10.111. If I try to ping 20, I should not be able, because I have not created any static route. Or we could also go ahead and create a default route pointing to the Palo Alto firewall in the distribution switch, which we could say for any network having any mask forwarded to 1.1. So I should now be able to ping 20 and even 2.1, sorry, and 3.1. So we are able to ping all those 6 networks from one another. Now let's go ahead and get rid of these static routes, and let's go ahead and configure RIP between these two, the distribution switch and the Palo Alto firewall. So what I will do is I will go ahead and get rid of the default route here, and also the other static route that we created, this one. I'll go ahead and get rid of that. So if I check my routing table, I only have the single host IP addresses, the local ones, and the connected networks. So I have no static routes or nothing as of RIP or anything else. So what I'll do is I'll go back to the PA central side firewall and default virtual router and static routes, and I would need to get rid of these networks, these static routes. So I'll delete them all and I'll say okay. Now I'll need to commit the changes, and let's go and configure RIP on the default virtual router here again. So we need to go to RIP, and from here you can go ahead and enable RIP, routing information protocol, on this default virtual router, and reject default routes. If let's say if this distribution switch is sends me any default route which I don't want to receive, because I want to only receive a default route from outside, or maybe I want to create a static one pointing to outside for any network being as of a default. So from the inside I don't want to receive any default routes if somebody else from inside sends me. So I'll go ahead and reject that default route. And bidirectional forwarding profile, what it actually does is, now we will talk about this one. Now if let's say, so let me create a quick topology here. So let's say if I have this router and another one here, and let's say another one here, and I have a network here which is network X, maybe this is by firewall, or maybe router or firewall, whatever. This is, let's say, B, and let's say this is C, and I have connections here. So A has an optimum path to reach to network X via this path, using RIP or OSPF or any other routing protocol or static. So this, let's say in this case we are talking RIP, so RIP right now. So RIP has decided to this being an optimum path to reach, because it's one hop away to reach network X. Now what if this path goes down? If this path goes down, now RIP would use its interval timer to wait for that period to finish and then fail over to the alternate path. Now we don't want this, because we cannot wait 30 seconds. Now in critical environments, we don't want to wait 30 seconds for the interval. So what I would do is I can create a bi-directional forwarding detection, saying that every, maybe now we talk in milliseconds, like every maybe 100 milliseconds or 1000 milliseconds, which is 1 second, every 1 second check the status of this link. If this link goes down, do not wait for the 30 seconds of RIP default interval timer. Do not wait for that period. Go ahead and fail over to this link. So I hope that made sense, that we don't want to wait 30 seconds to finish. That is the default timer used by RIP, or maybe OSPF 10 seconds or 40 seconds for the dead interval of the neighbor adjacency. We don't want to wait that period. We want to say, let's say maybe half of a second, 500 milliseconds. If this goes down, then fail over to the alternate for this network. So that is by directional forwarding detection. That's the concept here. Now there is a default one that's already there. We can create our own new. We can say, like, go ahead and create a new one. Now here you can name it, maybe let's say A or whatever, and here you can define the interval, the receive and send in milliseconds. They are basically in milliseconds. So it's good for critical infrastructures that you don't want to wait that default timers. Now here you can specify the interfaces that you want the interface to participate in the RIP routing protocol. What I will do is I will go ahead and select these loopback interfaces, and I'll also select the Ethernet 1/2 to participate in the RIP routing process. So I'll add the interface 1/2 and I'll enable this, and here you can enable and disable it. You can advertise default route here out of this interface. Do you want to advertise it? Let's go ahead and say, oh yes. Here you can modify the metric here, which we spoke which is actually not the admin distance. This is the hop count metric, because RIP uses hop count as of a metric. So you can modify this to being as of 1 hop away, or maybe 2 hops away, or whatever. Here we can go ahead and attach an authentication profile. Let's go ahead and create one. So I will directly go ahead and create from here. So I'll name it, let's say, rip auth profile, let's say. Do you want to use a simple password to be sent in as of clear text between these two, or if you want to encrypt that via message digest 5, which is using a 128-bit encryption? So let's go ahead and encrypt it. So I'll say add. So the key ID I'm using, it's a chain of keys, that in a chain you can have multiple keys. Let's go ahead and create the first one, and the key string that you can specify here would be, let's say, maybe test123 with a capital T, test123. And here you can select preferred or unpreferred. Maybe you have multiple keys in a chain and you want to prefer one over the other. So you can go ahead, because maybe you have other devices here. Palo Alto is using RIP with other device here and another one here, and you want to prefer one and over the multiple keys, because you may have keys, a separate key between a second this device, a separate one, and with this you may use a separate key, and with the other you may use a separate key. So now here you can prefer it, which one do you want to prefer, one over the other. So I'll go ahead and say okay here, and the mode is right now normal, because it would send and receive both out of this interface, the RIP updates. If you want this to be passive, now what happens is that you may have an interface here, another interface that's connected only to hosts, maybe in devices, servers maybe, or maybe some department, maybe HR department or finance department, and there is no device that talks or understands RIP updates there. So you don't want to send updates to that interface or that network. So what you can do is you can say mark that interface which is here to as of a passive, which would not send updates out of that interface, but the firewall would advertise that network to other devices that understands RIP and talks RIP with you. So here you can specify the mode right now, or you can say only send, do not receive anything, just send updates out of this interface, or you can say send and receive, which is the default mode here. And here for this interface you can specify attach a bidirectional forwarding here as well. Here if you specify a default bidirectional forwarding profile would attach to all the interfaces, here it would specify only for this interface. You may have other bidirectional forwarding profiles for every interface having different timers. So for each one you can go ahead and or you can say here inherit protocols global BFD profile, which will inherit the timers from this one, from the default the global one. So you can select this. Maybe let's go ahead and inherit it. The default is inherit, which would inherit from this one. So I'll say okay here, and I need to attach the other interfaces. I'll enable this add this interface to RIP as well. So I'll say okay, and I'll go ahead and add the second and third one. Okay, you can also modify the timers here. So the default for the interval is 1 second, and for the update intervals that are sent and received is 30 seconds. Actually sends are 30 seconds, and the expiry is 180 seconds, and the dead interval is 120 seconds. In Cisco it's 240 seconds, which is the flush update there. Here it is 120 seconds, the default update, and the invalid is same here, but the dead, they call it dead here, but they call it flush there. So it's 240 there, and it's 120 here. And the authentication profile we have attached here, we could create there, and we could also create here and attach it to any interface. We can create it here and then attach it here, or we actually went and directly created it. And the export rules, what you can do is if we use two or more routing protocols, and if you want to redistribute, we need to create a redistribution profile there first, and then we attach that redistribution profile here. If we may be using a rip between the distribution switch and the Palo Alto firewall, and maybe I'm using the OSPF as of a protocol between DMZ switch and the Palo Alto, and then we can redistribute between those two routing protocols, or maybe static routes, or maybe connected networks. So we can create a redistribution profile first, and then we can attach it here. We will talk about this later. So I'll go ahead and say OK here. We will do this redistribution later. Once we are done with OSPF and BGP and static everything, then we will go and do distribution. So I'll say OK here, and I'll need to commit the changes. Commit. And I'll go ahead and configure rep, and let's enable rep here on the distribution switch as well. So I would say route rep. So by default, when you enable rep on the Cisco devices, it's by default doing auto summarization to the classful boundary, where you can say is not to summary to not auto summarize to the classful boundary. And by default, when you enable it, it is rep v1, so you can convert it to 2. And networks, let's say add 21110. You can add one by one, or you could say 00 to add all the networks that exist in this distribution switch. And we also need to go ahead and create a keychain here, because we also did create it an authentication profile and attached it to the Ethernet 1/2 on the Palo Alto firewall. So we need to go ahead and create a keychain here. So keychain, let's go ahead and name it T for test, and key of, let's say 1, and key string is, let's say test 1 2 3. So we need to attach this keychain now to the interface, which is Ethernet 0/0, which is actually this interface that's connected to my PA central site Palo Alto firewall. And what is this error? I guess it was failed because of the passive mode. Okay, actually it's loopback interfaces, and they need to be in passive because they cannot be in normal mode, because they would not advertise rip updates out of that interface. We need to convert that. So let's finish this one, and then we will come back to that. We'll change it. So interface Ethernet 0/0 and IP rep authentication. The keychain is that we created was T, I guess, and enter. And the rep the mode is authentication mode is clear text or MD5 you want to. So we configured MD5 on the Palo Alto side, so we need to go ahead and say MD5 here. And what we need to go here is, now we need to go back here to the default virtual router rip and loopback interface, and we need to change this from the normal to passive, because these are loopback interfaces, and rip updates should not be sent out of these loopback interfaces. So we need to change that. And passive, okay, and passive for the third one, okay, and commit. So now we should, right now if I come here to the distribution switch, show IP route, I should not have any rip updates, but once this is finished, we should be able to see some updates if everything is configured correctly. So now this is the shadow previous. We will get rid of those rules. So now if I say show IP route, so I'm getting the default route which was advertised by the Palo Alto firewall, and I'm also getting these three networks. If I try to reach them, 10.111, I'm able to reach. And if I come here to more runtime, which where I can check the routing table of the default virtual router. So if I click here, I can see I should see 20 networks. So I'm able to see 20.110 to 2.0 and 3.0, and they are marked, the flags are as of active, which is, you can see the codes here as well. And the R means rip here, and they are learned out of these these interfaces. So, and the metric is 2, and this actually this is the routing table of for both the IPv4 and IPv6. If you only want to see the IPv4, you can say only IPv4. If you want to see IPv6, I have nothing right now in the IPv6 routing table of this default virtual router in the PA Central side. So this is the unicast routing table. If you want to see the multicast, I have nothing right now in the multicast routing table for this virtual router in this Palo Alto PA Central side firewall. So it's only unicast, and these are the codes that you need to have a look. You can check this, and forwarding table here, it also shows you that U means up and H means that it's a host, which are these loopback interfaces, and G means here gateway, and these are the MTU and interfaces, flags, next hop, destination, and static route monitoring. You see that for this destination network, I guess I created a path monitoring for the default route, which shows me down. I guess it is because of the because of this interface is down, I think. Let me check. Am I able to reach 888 or not? So I'm unable. I guess that interface is down. I guess I disabled it. So Ethernet owns 0/1 and no shit. And so I'm able to, it should come up now. This one should come up. So we can wait for this, or maybe, so it will come up now in a moment. So that is routing table, forwarding table, static, and here in the RIP tab, you can see the summary, the timers, and you can see which interfaces are added and pairs. I right now have only one pair here, and I can also check the routing table of the default virtual router of the PA Central side from the CLI as well. If we go to the firewall here, the PA Central side. So let me stop this ping. So we say show routing route to check the routing table of the PA Central side, and here you can see the flags as of A means active, and S means this is static, and H is host, and R is actually a rep, which is the codes are here as well. And out of these interfaces, these are the next hops. You can see them all here, and you can also see the forwarding information table as well by saying show routing fib to show you the forwarding information base here. So there you can see the networks, next hop, the flags, interfaces, and the MTU, and they are shown as U, up, host, or gateway. And you can also see the summary or the protocols. You can check by saying show routing protocols. Sorry, you can say summary. You can see the summary of all the networks, and I guess there are other options as well that you can see: the multicast table, the interfaces, the protocol, the resource, route, and summary. So I guess that is it for static route and RIP routing information protocol in the Palo Alto firewalls. I guess if now we come here, it should be up, the static route monitoring. So it's up now, the path monitoring. So because we created that, the path monitoring for the default in the static route here, we do have this one, and it shows me up that I'm able to reach this every 3 seconds. So I guess thank you.